In this video, let's learn about dimensional analysis. So we have a wave is set up in a straight string. By plugging it, the velocity v of the wave depends. Now depends can be written as proportional to on tension T in the string, its length L, and its mass M. So this can be written as V. This is equal to K, then tension L and M. And where K is equal to 1, so V is equal to 1 times TLM is TLM. Okay, at this junction, what you have next is to put the power of X, Y, and Z on the right hand side of the equation, something like this. So V is equal to T, power of X, L, power of Y, mass, power of Z. Okay, then the next thing is to convert all derived quantities to fundamental quantities on either side of the equation. So velocity is a derived quantity. Converting it to fundamental quantity, working with the formula is displacement over time, and this can be expressed as displacement is length. So you have length over time is equal to tension, power of X, length, power of Y, mass, power of Z. Okay, at this junction, this can be expressed as capital L T power of minus 1 applying indices is equal to tension is also a derived quantity. You convert it back to fundamental quantities. The formula is in brackets mass times acceleration power of X times length power of Y times M mass power of Z. So with this, L T power of minus 1 is equal to, in brackets, mass times acceleration is velocity over time power of X times length power of Y times mass power of Z. So with this, length time power of minus 1 is equal to, in brackets, mass times velocity is length over time, okay, then divided by time, all power of X times length power of Y times mass power of Z. So with this, length T to power minus 1 is equal to, open bracket, mass times L over T times 1 over T power of X times length power of Y times mass power of Z. L T to power minus 1 is equal to, open bracket, mass times L times 1 is L, T times T is T square. So you have L over T square power of X times L power of Y times mass power of Z. Okay, so with this, L T power of minus 1 is equal to, open bracket, M times L is M L over T square, all power of X times L power of Y times M power of Z. L T power of minus 1 is equal to, this can be written as, open bracket, M L T is to power minus 2, following the rule of indices, power of X times L power of Y times M power of Z. L T power of minus 1 is equal to, power X, we open the bracket, you have M power of X times L power of X times T minus power of minus 2 times power of X is power minus 2X times L power of Y times M power of Z. L T power of minus 1 is equal to, now collect like terms, M power of X, and then you also have M right here, times M power of Z times, you have L here, L power of X times, you have L here, L power of Y times T power of minus 2X. L T power of minus 1 is equal to, following the rule of indices, pick one of these base, so pick M, then you have the power X plus Z times, pick one of these, L, and then sum up the power. X plus y times t raised to the power minus 2x. Now, looking at the both sides of the equation, we have m here, we have l here, we have t here. We have l here, we have t here. We do not have m in the left-hand side of the equation. So we'll bring it in, but then we'll raise it to the power of 0, because anything to the power of 0 is 1. So m power of 0 times l power of 1 times t power of minus 1 is equal to, you have m power of x plus z times l power of x plus y times t power of minus 2x. At this junction, you will then compare indices. So compare m to m, l to l, and t to t. Something like this. M power of 0 right here is equal to m power of x plus z, equation 1. And then l power of 1 is equal to l power of x plus y, equation 2. And then t power of minus 1 is equal to t power of minus 2x, equation 3. And we divide m, you have 0 is equal to x plus z, equation 1. L cancel L, you have 1 is equal to x plus y, equation 2. T cancel T, you have minus 1 is equal to minus 2x, equation 3. Now the goal is to solve for x, y, and z. So from equation 3, right, you have minus 1 is equal to minus 2x. Let's now solve for x by dividing both sides by minus 2 by minus 2. Minus 2 cancel out minus 2. What you have is x is equal to minus cancel minus. You have 1 over 2 for the value of x. Inputting the value of x into equation 1 to solve for z, we have that in equation 1, 0 is equal to x plus z. So 0 is equal to x is half, then plus z. Now if half crosses over to meet 0, z is equal to minus half. With this, we've gotten the value of z. The next thing is to get the value of y. To get the value of y, input the value of x as half into equation 2. So from equation 2, 1 is equal to x plus y. So 1 is equal to x is now half plus y. Okay, so y is equal to, now half will cross over, you have 1 minus half. Okay, so y is equal to 1 minus half is plus half. Okay, with this, we've gotten the value of x as half, the value of y as half, and the value of z is minus half. Okay, so input the value of x, y, and z into this expression. The expression is v is equal to t power of x, l power of y, m power of z. V is equal to t. The value of x is half, 1 over 2 times l. The value of y is half times m. The value of z is minus half. V is equal to t power of half can be written as square root t times l power of half can be written as square root l times m power of minus half can be written as, power minus is 1 over, so m power of half is square root m. V is equal to square root t times square root l times 1 is square root tl over square root m. So V is then equal to square root TL over M. And this is the expression for V, T, L, and M.